Alright, YouTube, hello, thank you for watching. If anybody ever ends up with getting a base station that doesn't have a transformer in it, you know, my prayers are really with you, because I've been looking and looking for these transformers for a very long time. What they generally use in here is an 18-volt center tapped at 5 amps. It's an encased or shielded transformer. They have become completely extinct. So sometimes you got to do what you got to do. Durrell Electronics was selling 4s. I don't know if they had 5s. I don't remember. I know they had 3 and 4s, and they sold out of them just recently. So I thought about putting a toroid in here, which would actually be the best, but there's just not enough room here. Generally, they're either too small or they're too big. So I took what Durrell Electronics had left, and that was this big hogging son of a bitch. This is an 8 amp transformer here. Now you might be thinking, how the hell are you going to fit that in that radio? Well, somebody just told me not too long ago. They said, you know, you're a real master of shoehorning. And I never really thought about it, but yeah, I think they're right. So this is 18 volt center tapped at 8 amps. So it's 9 and 9. 9 on each side of the center tap. Now I cut the center tap off there. Let's just say, for example, the only transformer you could find would be 12.6 volts center tapped. And that would be the thing that is the most common item out there you can find. Once you rectify that, that's only going to come up to 17.8 volts on your power supply. And then if we subtract off 13.8, that only gives you a 4-volt window for regulation. That's why it's so tough getting a transformer in here, because these here, after it's rectified, 18 volts times 1.414 is going to be about 25 volts, which is what this regulator needs coming into it to make 13.8 going out of it. In a manner of speaking, I say that. I think I took the feed off this transformer because setting it in this way, of course, it's a freaking inch too tall. But I think what I can do is drop this guy down in this way, set him up on some standoffs, and then I use some fast-on connectors here just in case I have to pull this transformer out to send this thing somewhere. So I don't want to leave the transformer in it for shipping, because I guarantee this radio would be smashed to hell by the time it got somewhere. So I think what I want to do here is take these wires out to these pass transistors and reroute them through a different hole, and pop another fuse holder in there for the AC line, and leave this for the secondary. So that's the goal, is to get this bus holder in that hole back there and get the other wires out. I think what I'll do is clean this up a bit and rip this stuff out and pull these wires out the top of the board and take them to the heatsink on the top of the radio. I guess the first step here is just to chop these out. Easy come, easy go. Get these out of this hole. That way I can get the fuse in. So that's all the heatsink amounts to. There should be like some 0.25 ohm resistors on the emitters. They're just on the emitters to kind of equalize the current through the collector emitter junction, so one transistor doesn't run a lot hotter than the other. That's the only purpose for them. I wonder if I can just snap that. I didn't really predict that. There it went. Once that drill bit would have caught in between those holes, I mean, it would have tore shit up. Probably looked more like hell. I'll grind that off some. This is not going to be long enough. So I think I'll just transition these into Teflon wire because that's all. That's the only wire I have. If I had other wire that was like this, I would just tear this off and rewire this one solid piece. But I think what I want to do here is bring these down and tie them across there. And it's going to be just a little bit too short, so I'll just splice some other wire onto it and heat shrink it. And when you have to drill these fuse holders round, these sumbitches will always spin on you. I mean, that's a given. And this one is flattened on both sides, but I just don't I don't have no way to duplicate that technology. Can't really say I'm a big fan of those plastic nuts either, but I think it will hold up. There's just a little tiny bit of spooge around there. And I do remember thinking a long, long time ago, you need to buy 1 amp fuses. 1 amp, 250 volt. These fuse holders here, I'm not too stinking sold on these things. But you know I use them because that's what I have. I like the screw-in holders better. Something doesn't seem right here. Oh no, something is not right here. Really, I can't believe that Bus made these fuse holders. They aren't like any buses I've ever had. I think out of the 10 or 15 that I bought, I think I've used at least 2 or 3 of them to make one good fuse holder out of. This is missing the spring. That's the crucial piece. How in the hell can I have all these fuse holders but not have any springs for them? Well, there's one. Yeah, there's one that's got a spring in it. Like I said, these fuse holders are not 2. They just don't always work out. So that'll get me my line fused at 1 amp. That will be good for 125 watts. So if the transformer's 60% efficient, means if you're drawing roughly around 75 watts of power out of the secondary, you might be kind of tweaking that fuse a little bit. I don't think it will ever blow, but if it does, I could put an 1.25 amp or 1.5 amps in there, but no higher than that. Not sure why that cap lead is, why that damn cap is so cattywampus there. That is the base. Now the key is to flip this sumbitch around and not have all the wires spring out of the holes. While it's caught on scope probes, line cords, and a million other things it's all caught on. If there's anybody out there that thinks that doing electronics work is relaxing, let me just be the first to tell you it is not. It is not. I was so mad at this thing the other day. I was actually so mad at this radio the other day. I picked up the wire cutters and I was almost just ready to do it. But then I decided if you do that, it's just going to give you more work. I was going to cut the sumbitch and line cord right off of this thing. Because you know what? As messed up as this sounds, you know, I've spun this sumbitch around my table here probably 3,000 times in the past couple weeks. That's how many times I've went to front and back on this radio. And you know, after the first 500 times, your nerves really aren't worked on. But when you get to 3,000, you'll cut the line cord right off of these things. That's why one of the things I do at some point in time, if it's a radio that I'm going to keep, is I rip this sumbitch right off of here and put an EIC cord on it. I haven't done that on this radio here because I'm not so sure that I'm going to end up keeping it. It's a lot of work to chew a square hole out on the back of these radios. These chassis, they're hard as hell, man. So these three here, when you put one of these heat sinks on the back, it really kind of screws you up. Or it can, because there isn't much room on the bottom of the chassis to get your fingers into fuse holders. Well, it goes in that one. Not sure why I had a short screw in one of these, other than to say I probably probably ran out of screws. It's in the hole, but my guess is the heat sink's probably not square. So I probably need to shift this one way or another. Well, I'll tell you what, that thing's like dead on. I ain't never had that happen. I'm not a big fan of this heat shrink by any means, because it shrinks at unbelievably low temperatures. So depending upon what size wire you're putting it on and how close to the soldering point you are, the heat shrink might end up shrinking, and then when you try to pull it over top of what you just soldered, some bitch and shit don't fit no more. Now you might be thinking, doesn't that hurt your fingers? You get used to it after a while. It really gets you when you're on the damn silver plated Teflon wire here, because the heat goes through this shit like it's absolutely nothing. Yeah, it does burn a little bit. That'll work. Damn fingers. Damn fingers are cramping up on me. Sometimes I go to do something and my fingers just lock up on me. Like if I'm trying to get my keys or something to go in the door. That's a messed up thing. There we are. 2 fuse holders in it now. You know what? While I'm thinking of it, maybe the reason I'm having such a hard time here isn't because there's something wrong with me. Maybe there's something wrong with this radio. 13 3/4. That's a fucking problem. That's why this son of a bitch has been literally making me lose my mind with thinking about cutting cords off of it and this and that. It's not me, it's this radio. This thing's a hell of a lot deeper than what the other radios are. You know, excuse my dumbness, but you know, I just now noticed that. This thing's 13 3/4 inches deep. That's 11 3/4. That's the whole difference to the mental health right there. Oh, that's why I can't pull them through there. They got a high meg resistor tied here to the chassis. I gotta get some new wires on here. That's gonna kind of complicate things for me. These things here can be a real pain in the ass. Oh my, come on, for the love of God. Kind of smash this side down some more to get the cord crimped in there. And like I said, them things are a real pain in the ass. Get crimped too much. Screwdriver in there and try to expand it back out. Probably the best thing to do, as much as I hate to do this, is just leave their stupid crimp cap on there. It does have a little bit of wire to it, so I can strip this back, but getting a wire nut on there is going to be pretty hard to do when you can't grab a hold of the wire directly. You gotta be shitting me. Just can't even believe these idiots. These go through there. These go on here. Those go on there. Like so. Many, many, many F words later. Now these wires here are going to have to go down through. You got to be shitting me. Like so. Boy, it sure would have been easier if I could have got the right size transformer for that. That's about all I got to say about this project. So in reflection, it really doesn't do you any good to have quick disconnects on your transformer, at least on the secondary, when you got to go through so much other shit to get the transformer out. That's pretty much what I'm trying to say to you. Well, I don't really like that, but I just don't have another choice at this point in time. So this wire here needs to come down and go onto there. Hell, that thing don't even solder. Well, the insulation has no problem with melting. But I'll tell you what, the copper doesn't even take solder. What a bunch of junk. Solder won't even flow on it. That wire definitely takes solder. That ought to show you the kind of stuff we're dealing with today. You know, I don't really like that wire nut laying there, but guess I got no choice in the matter. Well, it is what it is. That's really the best I had to work with. Just had to cut the wire off in the cap there. Ain't much more I can do than that. That's really about as good as it gets there. What a shit pile of mess. Well, it's improved. It's probably 3 or 4 pounds heavier than it's supposed to be. These points here won't be so much of an issue. they're an angle here. They're not going to be too quick to bend. This one here, I mean, it could sag 40,000 years from now on a chassis. I just don't know. So as I always seem to say, when you make one change in electronics, it generally forces you to make another change. Kind of backing up here, I put this standoff on there. That way you can mark the center point and drill a hole out in the bottom cover, and then screw another foot right here where this is at, and have that foot and the bottom cover of the chassis set on this standoff. That way it distributes the weight of that transformer. It's a pretty easy way to assure that the chassis stays straight with the added weight. So what I did here was I essentially put a regulator in series with a regulator. Kind of the downfall of these radios, the way I kind of look at them, is they have an awful lot of voltage setting on the collector or the pass transistors. And the more voltage drop you get across the collector emitter junction, the hotter these things get. According to the factory schematic, it was supposed to have roughly 25 volts, basically 25 volts setting on the filter cap. And I have a feeling that was not a full load voltage. The full load voltage, I think, would have been a little bit lower than that. These are actually supposed to be, like I think I said somewhere, the secondary of this transformer is supposed to be like 17.2 volts AC, which would give you 24.3, but the schematic says 25.4. Regardless, anyway. So when I put this big hogger in here, the voltage on the filter cap was setting at about 29 volts. Of course, it does come down under load, but when the radio is just idling, of course, there's a higher voltage setting here on the collectors, and that puts more heat load on them. So what I did was put a regulator in series with a regulator, put a 24 volt regulator on here, which these guys will handle an amp. I used that in a shunt circuit with a PNP transistor. So you can see this PNP setting down here where the original regulator was until I moved the regulator transistors on the back. This heat sink that was sitting around here was kind of freed up to be able to take some heat, if you get what I'm getting at. So it made sense to me to put another series regulator in here and transfer some of the heat load off of this guy back here onto the original heat sink, because of the increased amount of voltage setting on the collectors. So what I did is I sheared across here. This is the filter cap right there. So it comes off the filter cap, goes through this 24 volt regulator, using this PNP as a pass transistor basically in shunt. And then it feeds 24 volts onto the collector of these transistors here. So by doing that, you will cut down on the amount of voltage across the collector emitter junctions. It's kind of like a seesaw basically. If you have too much power being dissipated across one, you can kind of finagle some of that power out by putting another regulator in series with it and shifting some of the current back onto this heat sink, if that makes any sense. It's kind of hard to explain, but if I put it on paper, it would make perfect sense to you. So I adjusted this power resistor down to 4 ohms, which is going to be about 3.5 amps. This is a 5 ohm resistor here. So if we plug this guy in, we get 13.87 coming out of it. And I'm basically connected on the emitter of this pass transistor here, where it comes up and goes onto the regulator to put power throughout the radio. If I put a 3.5 amp load on there, drops from about 13.88 to about 13.6. That's pretty acceptable because there's voltage drops on the wires here and shit like that. And those regulators, the way they're made, they're not great to start with. So if we look at the voltage on the filter cap, we're setting about 28.32. And when we load that up, it's dropping to about 22.75. Coming out of the 24 volt regulator, we should have 24 volts right there, which is feeding this back here. But this regulator will drop out of regulation because there isn't enough headroom for it. And when we load it, it's dropping to 20.3. So effectively, under load of 3.5 amps, we're putting 20 volts setting on this collector back here instead of something that's probably about 4 volts higher. What's important is we've taken some of the heat load off of this back here by reducing the amount of voltage that's going to be dropped across the collector emitter junction of these two pass transistors back there. Now, one thing I've noticed on this regulator board in this 142 is it's not what the schematic says it's supposed to be. I'm not sure why that is. I checked a SAM schematic and I checked another source of an online schematic, and both of them have this regulator board a bit differently. Here where this R304 is, there should be an R305, which is a much lower value resistor. This is 3.3K. The R305 is a 220 ohm, and what that does is it basically holds the base of this driver transistor high. But there's a Zener diode, a 16.2 volt, that goes from that point to ground, which basically limits how high the power supply can swing upwards in voltage. Indirectly, your voltage control does that too, but that Zener diode in there is basically an override. In the event that this voltage control pot malfunctioned in some way, shape, or form, if the wiper opened on it, or if the ground leg suddenly didn't work anymore or something like that, this voltage regulator would just sling up to basically full filter cap voltage. And I'm not sure why this board wasn't made the way Sam says it's supposed to be. So this resistor here will have to come out, and there's going to be a very low value go into there, which is actually going to feed current through the Zener diode. So this is probably going to get changed down to less than the 220 ohm value their schematic says it is, probably down to more like 100 ohms, because my supply voltage coming into this is slightly lower with this dual regulator kind of series thing in it, if that makes any sense. So that's about all for this power supply project here. The next video is going to go back onto this DDS VFO here, which is a whole can of worms. So, hey, I appreciate you watching my video very much. Take care and have a great day.